Okay students, this is the formula for oxalic acid. COOH twice can be written as COOH single bond COOH. It is treated with sulfuric acid H2SO4. So on the addition of this H2SO4, a molecule of water is removed. From the first COOH, hydrogen, then from the second COOH, OH. H and OH together called as water molecule. Okay, then remaining what is there here, COO, that is CO2. Okay, then here CO, that is carbon monoxide. So CO2 plus carbon monoxide plus H2O. So it is the dehydrating nature of the oxalic acid. Okay, so in the dehydrating nature of sulfuric acid, we have seen three examples. What are they? First one, sucrose with water molecule. It results the removal of sucrose with sulfuric acid. Water molecule is removed along with the formation of carbon atoms. Then formic acid on reaction with sulfuric acid, it results the formation of carbon monoxide along with the removal of water molecule. Then finally oxalic acid, COOH twice plus H2SO4, it results the formation of carbon monoxide, carbon dioxide and removal of water molecule takes place. So these three are the examples showing the dehydrating nature of sulfuric acid. It is very important 3-mark question. Explain the dehydrating nature of sulfuric acid. Like that the question will be asked. Okay, Mama? Okay, then we can discuss the remaining chemical properties of sulfuric acid. Okay students, these are the chemical properties we are going to discuss now. There are 7 chemical properties given in your textbook. Let us see them one by one. Okay, the first one is decomposition of sulfuric acid. Then second one is oxidizing property. Third one is reaction with metals. Fourth one is reaction with salts. Fifth one is reaction with organic compounds, and sixth one is acidic nature. Okay, so these are the properties we are going to discuss now. What are they? The first one is decomposition, oxidizing property, reaction with metals, reaction with salts, reaction with organic compounds, and the acidic nature of sulfuric acid. Okay, let us see them. Okay, my first one is acidic nature. Okay, how we can define an acid? An acid is a substance. It has to react with a base, and that should result the formation of salt. Such kind of substances will be called as acids. Okay, so in order to confirm the acidic nature of sulfuric acid, it is allowed to react with a number of bases, that is sodium hydroxide and ammonia. Okay, so first in the first equation, sulfuric acid is reacting with sodium hydroxide, and that results the formation of sodium bisulfate. Okay, so sulfuric acid formula H2SO4, sodium hydroxide formula NaOH. When these two are reacting, it results the formation of sodium bisulfate along with the formation of water molecule. That is, generally we can write acid plus base, it results the formation of salt and water. Okay, so from this we can confirm the acidic nature of sulfuric acid. When sulfuric acid is reacting with a base NaOH, it results the formation of a salt, that is sodium bisulfate, along with the formation of water molecule. Then second one is H2SO4, when allowed to react with sodium hydroxide, it results the formation of sodium sulfate, that is Na2SO4. It is also a salt along with the formation of water molecule. So salt and water. The next, sulfuric acid on reaction with ammonia, it results the formation of ammonium sulfate, a salt. So generally we can say when sulfuric acid is allowed to react with a base, it results the formation of sulfate and bisulfate. So from this we can confirm the acidic nature of sulfuric acid. Okay students, the next chemical property we are going to discuss is oxidizing property of sulfuric acid. Okay, so we know what is oxidation. The addition of oxygen to any compound is termed as oxidation. So for that purpose, for that oxidation process, sulfuric acid is helpful, so that we can call this sulfuric acid as an oxidizing agent. Okay, generally this sulfuric acid on decomposition, it will be converted into a molecule of water, sulfur dioxide and atomic oxygen, and this oxygen is responsible for the oxidizing nature of sulfuric acid. Okay, let us see the oxidizing nature of sulfuric acid with some examples. Okay, first, the sulfuric acid is treated with carbon. When an atom of carbon is treated with sulfuric acid, this carbon is oxidized to carbon dioxide. That is, carbon is reaction with oxygen atom of sulfuric acid, and it is oxidized to carbon dioxide along with the formation of a molecule of water and sulfur dioxide. Okay, then second oxidizing property is, when sulfuric acid is allowed to react with sulfur, it will be converted into sulfur dioxide along with the formation of water molecule. Okay, then next example for the oxidizing property is reaction with phosphorus. When sulfuric acid is allowed to react with phosphorus, it results the formation of phosphoric acid, or simply we can say phosphorus is oxidized to phosphoric acid. So dear students, these are the examples illustrating the oxidizing nature of sulfuric acid. In the first example, carbon is oxidized to carbon dioxide. In second one, sulfur is oxidized to sulfur dioxide. And in third one, phosphorus is oxidized to phosphoric acid. Okay, so with this, the second chemical property, that is the oxidizing nature of sulfuric acid, is over. Then we can discuss about the reaction of sulfuric acid with metals. Okay, so generally we know when acids are reacting with metals, it results the liberation of hydrogen gas from the acids. Okay, so here the example taken is reaction of the metal zinc. When zinc metal is allowed to react with sulfuric acid, it results the formation of zinc sulfate salt. Along with that, hydrogen gas is liberated. Here zinc is there, and from this sulfuric acid, SO4 is there. So zinc plus SO4, it is converted into zinc sulfate along with the liberation of hydrogen gas. Okay, then second one, aluminium. The aluminium metal on reaction with sulfuric acid, it results the formation of aluminium sulfate, Al2SO4 thrice, along with the liberation of hydrogen gas. Okay, so here aluminium and here sulfate, so these two combined together and results the formation of aluminium sulfate. Okay, then next one, reaction of the metal copper. When copper is treated with sulfuric acid, Cu plus H2SO4, it results the formation of copper sulfate, a molecule of water, and here sulfur dioxide gas is liberated. In the first two examples, that is the reaction with zinc and reaction with aluminium, hydrogen gas is liberated, but only with the metal copper. When copper is allowed to react with H2SO4, what gas is liberated? Sulfur dioxide gas is liberated. Okay, so the third chemical property, that is the reaction of sulfuric acid with metals, is completed. Let us see the next chemical property. Okay, the next chemical property of sulfuric acid is reaction with salts. Okay, we have taken two salts in this case. The first one is potassium chloride, the second one is sodium carbonate, KCl and Na2CO3. Okay, so simply we can say when sulfuric acid is allowed to react with salts, it results the formation of sulfate and bisulfate. SO4 sulfate and HSO4 is bisulfate. Okay, when KCl is allowed to react with H2SO4, it results the formation of KHSO4, that is potassium bisulfate. So H2SO4 you can write like this, H, then HSO4, that is H plus HSO4 minus. So this H plus will combine with this Cl and that will be liberated as hydrochloric acid. Then remaining, what do we have? Here potassium is there, here bisulfate ion, that is HSO4. So these two will combine and that will be removed as KHSO4, potassium bisulfate. Okay, then sodium carbonate, Na2CO3. a reaction with H2SO4. Okay, here this Na will combine with this SO4 and it is converted into Na2SO4, that is sodium sulfate. Then here CO3 is there, no? From here one oxygen will combine with this H2 and that will be removed as H2O. Then if one oxygen is removed means here we have CO2, so we can write Na2SO4 plus H2O plus CO2. So these two are the reactions explaining the reactivity of sulfuric acid with salts. There are two salts we have taken. Those are potassium chloride and sodium carbonate, KCl and Na2CO3. It results the formation of sulfate and bisulfate. Okay, then next chemical property is reaction with organic compounds. We are going to see how this sulfuric acid is reacting with organic compound. Only one equation is given to explain this process. We have taken the organic compound benzene. It is a well-known compound to all of us. It is benzene. Do you remember the formula of benzene? Yes, it is C6H6. Okay, ma. So in the organic chemistry, this reaction is very useful since it is used for the synthesis of benzene sulfonic acid. Okay, sulfonic acid means the compounds bearing SO3H groups are called as sulfonic acids. Okay, so when benzene is reacting with this H2SO4, it results the formation of benzene sulfonic acid. The structure of benzene sulfonic acid will be like this. In a benzene ring, what group will be there? SO3H group will be there. It is benzene sulfonic acid. Okay, dear students, this mechanism consists of 3 steps. So simply we can study the reaction and we can memorize it. Okay, so with this the chemical properties of sulfuric acid is over. Then finally we have to see about the test for sulfate or sulfur. Okay, how to find the presence of sulfate radical in a salt. Okay, it is this is the test we are performing in the laboratory. In the qualitative analysis, the test for sulfate is the same. Okay, in your 11th standard, you have undergone your practical, that is salt analysis. There, for finding the sulfate radical, we will perform barium chloride test. The same test is given here in the form of equation. Okay, first one, when barium chloride solution is added with H2SO4, it results the formation of barium sulfate. It is a white precipitate. Okay, if any compound possesses sulfate radical, that is SO4, we can easily confirm by adding a solution of barium chloride. At that time, it will result the formation of a white precipitate, and the white precipitate is barium sulfate. So in this reaction, if you get a white precipitate, we can confirm the presence of sulfate. If there is no white precipitate, we can say that the given compound doesn't possess sulfate radical. Okay, then second test suggested for the presence of sulfate radical is lead acetate. This is the formula for lead acetate, CH3CO twice Pb. Lead acetate with sulfuric acid, it results the formation of lead sulfate, PbSO4. This also will be a white precipitate, along with the formation of acetic acid. So in both the processes, if we obtain a white precipitate, we can confirm the presence of sulfate radical. Okay, so what are the tests suggested for the identification of sulfate radicals? The first one is barium chloride test, second one is lead acetate test. Okay, okay. So with this, all the chemical properties of sulfuric acid over. Let us recollect from the beginning once again. Okay, sulfuric acid, H2SO4, it can be prepared from 3 different processes: Chambers process, cascade process, contact process. Then contact process we have discussed. It consists of 3 steps. In step 1, formation of sulfur dioxide. Step 2, formation of sulfur trioxide. And in step 3, formation of sulfuric acid. Okay, so this is the method employed for the preparation of sulfuric acid. Then next we have discussed about the physical properties. Sulfuric acid is a colorless viscous liquid. There is a hydrogen bonding exists between the molecules. Then freezing point and boiling point we have seen. It is soluble in water with any proportion. The next one is dehydrating nature. Sulfuric acid is a very good dehydrating agent. It can remove water molecules from sucrose, formic acid and oxalic acid. So this we have seen. Then we have discussed about the chemical properties of sulfuric acid. There were 6 chemical properties given. Those are decomposition. So decomposition is simply the H2SO4 will be decomposed into water molecule and sulfur trioxide. So decomposition, oxidizing property with metals, with salts, with organic compounds and the acidic nature. Okay, first we have seen the acidic nature. So when sulfuric acid is allowed to react with base, either NaOH or NH3, it results the formation of sulfate and bisulfate. The next one, oxidizing property. The oxidizing properties of sulfuric acid, it oxidizes carbon into carbon dioxide, sulfur into sulfur dioxide, phosphorus into phosphoric acid. Okay, then with metals, zinc metal on reaction with sulfuric acid, it forms zinc sulfate and hydrogen gas. Then aluminium on reaction with sulfuric acid, it forms aluminium sulfate and hydrogen gas. Copper on reaction with sulfuric acid, it forms copper sulfate and SO2 gas. Okay. Next, with salts. With potassium chloride, it forms potassium bisulfate. With sodium carbonate, it forms sodium sulfate. Then with organic compounds, that is with benzene, it forms benzene sulfonic acid. Then test for sulfate. There are 2 methods for identifying sulfate radical. Those are barium chloride test and lead acetate test. In both the tests, white precipitate will be found. Okay, okay. So with this, the concept of sulfuric acid over. Go through and learn well. Thank you.